All right, going to try to fit 2 into this one here. Haven't been doing too good a job of that, this particular chapter. This one's right out of the book. It's problem number 13 from section 5.6. The market value of the 1993 to 95 Porsche 928 had a recent upswing, increasing from $8,000 in the year 2000 to $15,400 in 2015. Assuming the value of the car has grown exponentially, then we want to find out the equation that describes the growth, how much it's going to be worth, or how much it was worth in 2011. When will it reach twice its original price, right? What is its doubling time going to be? And then when will it reach $25,000? I have no idea where they picked that. Seems pretty arbitrary. The difference between this and the ones we've been dealing with previously is we're not given a growth rate here. We're going to have to find the growth rate. We know that the value of this car, I'm just going to use V, right? The current value is going to be the original value, $8,000. That's consistent with the last few problems we looked at, times the rate times the time. We're going to have to find the rate ourselves this time, though, and the way we're going to do it is we're going to use this year here. If we call this the starting point, then we know that after 15 years from 2000, the value is going to be $1,540. So we know that it would be $15,400, excuse me. Started at 800, the rate, and we know that it's going to be that value after 15 years. Okay, so we use our initial time to find the starting value, and then we use this other time to plug that in here, and we can solve this to find what the rate's going to be. And it's not too tough to solve. It's always going to be the same. You're always going to divide both sides by the initial value. So I left the E out of the whole thing. I'm sorry. This is 8,000 times E to the R times T. So this is 8,000 times E to the R times 15. When we divide both sides by 8,000, we're left with E to the R times 15 there. We need to get that out of the exponent, so we're going to do the natural log of both sides. That's going to give us the natural log of 15,400 divided by 8,000. And on this side, natural log and E, haven't really talked about it this way, but they're inverse functions, which means they cancel each other out. So like if you have an x squared and you square root it, they just go away. Or if you have a times 2 and divided by 2, they cancel each other out. Same thing here. The natural log and E will cancel each other and leave us with R times 15. Divide both sides by 15, and that'll give us R. And that is definitely calculator work. That's going to be the natural log of 15400 divided by 8,000, and then divide that whole thing by 15, and we get an R of 0.045. All right, and we're not done. This and the next couple problems are going to be long, so I don't know why I thought I'd be able to get a couple of them in on one recording here. We now know that the actual equation is 8,000 e to the 0.045 t. We found our rate. This is always going to be the same. Natural log of the new value over the old value, so this divided by that, and then that, the natural log of that divided by how many years. So if you want to keep that as a shortcut, it's a good one. We can use this equation to do all the rest of this. If we put 11, right, from 2000 to 2011 would be 11. The value of the car then would be 8,000 E times 0.045 times 11. Remember to put parentheses around that. I'm not going to spend the time on video here putting that into the calculator, but it's very easy to do. To answer these questions, this one, when's it going to be 16,000? That's the doubling time. So our doubling time is going to be always the natural log of 2 divided by 0.045. Right? So the answer to our first question is that right there. The answer to our second question is natural log of 2 divided by 0.045. And then to answer this third one, we could go back to the calculator and we could graph our function here, and we could graph our horizontal line at 25,000 and find where those intersect. That's the way we've done that all through this course. But we've got a different way to do this here, which is we can set 25,000 equal to 8,000 e to the 0.045t. And we can do exactly the same thing we did right here. Divide both sides by 8,000. That'll get rid of that. Take the natural log of both sides. That'll get rid of that. And then divide both sides by 0.045. And that will give us how long it will take for that car to get to that price. And I will do that one real quick here. That's going to be the natural log of 25,000. Divided by 0.045. That's what it looks like when you type it in. Less reflection on it. And then enter, and we get about 25 years. Which I hope makes sense. After 15 years, it was up from 8,000 to 15,000. So it had about doubled in 15 years. And we want to know how long it will take to get to 25,000. That's not quite doubled again. So it's not going to be quite 15 years. Ends up being about another 10 years. One more video on this section, and we'll be done with it, and you'll be done with the chapter. See you again.